Okay, people, welcome to another session of John Science Fair Project. This is the flow chart that I promised y'all. This is going to show where we're going with this project and what we want the end result to be. All right, this is overall where we're going for this leg of the project. We got the Cerebro GX, a Quattro, the Lynx distributor, a couple of charge controllers, the power supply, which is what we're building with the alternator and the DC motor. We got a battery bank, and we have a shunt. And we have a couple of cutoff switches. We'll be adding some circuit breakers and some fuses and things as we go along, just to make this thing safer for us to operate and to make it safer for the vehicles that you guys put them in. Last thing we want is to set something up to where you can burn down a $100,000 or a $400,000 setup. All right, this is the power supply. We have our DC motor in the blue. You guys have already seen that. That's the VVOR. It's a 1 horsepower, 12-volt motor with a pulley on it. Then to the right, we have an alternator. And we already know that with the battery, that motor will power up the alternator. So now it's just a matter of getting everything to work together. To do that, we have a power switch right here. Is a controller for the motor. This here little switch right here will allow us to control the speed. If you can recall, in one of my videos, we did an RPM test on the motor and on the alternator, and they're spinning at almost 6,000 RPMs. That 6,000 RPMs is really high. So we have to put this in to regulate the motor. And it also comes with a handy dandy shutoff switch that's designed for DC motors. And then we're going to be putting in a battery bank manager by Emily and Clark's Adventures LLC. That'll help us manage the power and not to overcharge, and help with a cutoff for our motor and our alternator so we don't wear it out. This here is an RPM gauge. This is so we can take and put it on the DC motor and gauge how fast that thing is spinning. Once we can decide how fast it's going, we can check the amps on the alternator, and we can make sure that the alternator is spinning fast enough, and we can speed up and slow down our DC motor, and this will tell us, this here will tell us just how much it's got to go up or down. Then the next thing over is a DC voltage gauge. What it does is the top line will give us the voltage, and the bottom line will give us the amperage that the motor is using. And we have another one to put on the DC motor so we can make sure that our motor and our alternator are using and putting out the right amount of power. These are our DC to DC charge controllers. These here is what's going to allow us to control and condition the charge that the alternator is putting out for the rest of the system. It'll also help to negate any possible overages, like some power surges and inconsistencies. I'm pretty sure a lot of you have seen brownouts and everything else. Well, last thing we want is to cause that by having bad equipment. These here are the Orion Tri-Smart 2412 by 30s. These here can handle a 24 or a 12 volt circuit at 30 amps. They're non-isolated DC to DC charging. These here, we're going to hook them in parallel, and it'll control 60 amps out of our 100 amp alternator. Now, why do I not have enough to control all 100 amps? Because I wanted to leave some power to power up the motor and to power up the battery, basically to keep our loop going. Now, I can take and add another one because I don't think 40 amps is what's needed, but this is a starting point. This will help us get the system working, and then we can get into fine tuning. What I mean by fine tuning is if we need more amperage for the batteries, we can take more. If we don't need as much or we got enough being wasted, then we can get another controller added to the series. The basic point of doing this is to show you that it does not matter when you get stuff. You can take the system and build it slowly. You can do it to your budget and be able to get to where you would like to be. And I'm just showing a path on how to get there. This is where we are and where we're going. This is our battery bank. The Duralast Gold battery is what I'm using right now. That's a lead acid battery for my car. This battery is a dual purpose grouped battery, which basically means it can run a car and it can slightly be used as a deep cycle battery. So I don't have to stay above the 50% for its power. I can dip below it, but not too far. This battery, though, if it's being used as a deep cycle battery, is only rated for 51 amp hours. And since we're only using one, it's only going to put out 612 watts. Now, our alternator would probably recharge that in a hurry. Now, the Enduro Power Baja battery line at 300 amp hours per battery is where I'm going. This is a relatively large battery bank. However, doing it in a 12 volt configuration will give us about 2,400 amp hours at 28,800 watts maximum with a 12 volt system. I've done some research. I can kick this thing up to a 24 volt by just reconfiguring the batteries and reconfiguring our charge controllers. And I can double our, I can cut the amp hours down and almost double the wattage. But I think with the way the system is right now and tuning with either a bigger alternator or whatnot would be good, because 28,800 watts is about a little bit more than half of what it takes to power my house for an entire month. My electric bill was, for one of the months that I'm aiming for, was 45 kilowatt hours, which, for whoever doesn't know that, the 45 kilowatt basically means I use 45,000 watt hours through the whole entire month. That's all my hours added up for the amount of energy that I consumed on a grid powered house. So I'm trying to take this thing off grid. And this is a good point to kind of start fine tuning. The battery bank will be large enough. It's just a matter of getting an alternator that can charge it in the time that I want it to charge, which my target is about within 8 hours to fully recharge the battery bank. I want the alternator to only have to run from like 9-10 o'clock at night to 4 or 5 in the morning. And I can adjust the times. I want it to run for about 8 hours, no more than that, and have enough power to last me through the whole entire day. This here is what they call a smart shunt. Is we put it in the power line, and it can let us know what our battery voltage is and helps us to monitor our battery lines. You can find out your voltage. You can find out what your current is, your power that you're putting out, how much amp hours you've already consumed, how many hours you got remaining on what you have for a charge, and even can segregate out a starter battery for those of you that need starter batteries. This here's the Lynx distributor. I talked about putting in fuses and stuff. This here Lynx distributor will allow us to take and put our negative lines on the bottom bar where the black tip is. And then right above it, you'll see 4 studs that don't go all the way up to the red bar. That's because we can put a few, or we're supposed to put ANSL 100 amp fuses in, or whatever fusing we need to. And this here will basically act as a positive and a negative fuse bar and bus bar. So we're kind of tackling 2 things at one time with this while providing a bit of safety. So we're not overloading and we're not having anything else to take too much power. This here's our Cerebro GX. This thing can monitor just about anything. If you look at the red square, it says shore. What that basically means is that's how many watts are coming in from shore power because they're plugged in to a pedestal or whatnot with an RV. The AC load is what's outgoing into the RV. And where it says absorption, that's a Victron Energy power inverter / charger. We're going to use the Quattro in that position. And this will tell us how much power is being taken through it. And it'll tell us how much power is taking for shore power. In the bottom left corner of the screening, it'll tell us how much percentage we have left on our battery, how many amps we have, how many volts we have, and we can see how it's all going. And to the bottom right is a PV charger line. That there is for the MPPT when you have solar panels hooked up. However, they have come out with a version that has the DC line on it. So we can actually monitor how much power is coming in from the alternator into the system. So we know how much is coming in, how much of that is going to charging the batteries if we're up and using it. And we're also using, it'll also show us how much is being put out to the inverter for whatever AC loads that we have going on. So this is a good little tool to monitor income and outgo from all sources. And as you can tell, this system is meant to be used with solar panels as well. All we have to do is add the controller for it. With this system that we're building, we just add a couple of controllers, and you could add solar panel to charge batteries during the day while you're up and using them. And you can use the alternator and set it for nighttime use to charge the batteries up while you're sleeping so you wake up with 100% charge. Sounds awesome, doesn't it? This is the Quattro. This is the main piece. This is what's going to control everything. And when I mean by everything, I mean literally everything. This will control and coordinate and invert any power coming in from a generator, from the shore power, from solar panels, from alternators. Everything will go right through this and then come out of this and into your circuit breaker panel for the rest of your rig or your house. And trust me, this thing can handle it all. It's designed to. Otherwise, I wouldn't even be looking at it. This is some of the stuff that we'll be putting in for safety. We'll be putting in a Lynx power in box that's specifically designed for bringing power in from your batteries, especially when we start getting into lithium batteries where we have to hook them in parallel and in series to get to the ratings that we need. And then we have the bus bar that's in the middle. You're going to have one in red and one in black, mostly for a lot of the alternator stuff. When it comes to going between components, like the batteries and the motor or basically from our power supply to the batteries to the inverter. I'm wanting to have a couple of switches in there for cutoffs, and I'm wanting to have a lot of the ANSLs in there. This here are shut-off switches. We can take and use these to cut power in specific spots so we can work on the system and not worry about getting electrocuted. These here are the ANSL. These are the ANSL fusible links that we're going to be putting into the links distributor. These will help us maintain our voltage amongst the other parts that we need to have. This here is just a spot that I reserved for some DC powered circuit breakers that I'm gonna need to source and find yet. So we can actually have something in here to trip in case we either have an alternator that puts out too much power or a battery that decides to draw too much power. To me, you can't have enough safety features in place as long as they're not counteracting one another. Now, these are some of the future upgrade things that I'm looking at putting in. This here is a LinkSmart BMS. We start dealing with lithium batteries and a battery bank. We want to have one of these here in place to help control a lot of the stuff. And trying to stay with Victron Energy for 99% of the components because they'll make it for ease of playing nice together. This here in the bottom right corner is a battery balancer. When you get into doing like two 12-volt strings, like you do one series in 12 volt, and then you do another series in 12 volt, and then hook both of those in parallel, you can start throwing battery banks out of whack. When the voltages become inconsistent and not the same between your batteries and your battery bank, this battery balancer will take and pull the charge from one that's high and pump it into the one that's low. It does it at like a 0.01 current, and it'll help protect our batteries and keep them powered up and balanced. If you're running them all just in series, you really don't need to worry about it. This is mostly for people who are running more than one battery bank. So people with 24-volt systems and higher, they would use one of these to make sure that both battery banks stay in sync with one another. This here is an MPPT 15070TR VE.CAN smart solar charge controller. You can put one of these in line with solar panels and hook it right into the links distributors to run right along the side of the alternators. This here is a smart battery protect right in the middle. This here is to help protect our batteries from being overloaded, and it'll help us monitor the temperature of said batteries. When the batteries become too hot, it can tell everything in the system to shut down and give them a chance to chill out. And it'll also send you a warning telling you what in the world is going on, what the temperatures were, and that you have a problem. Now, in the top right, this here is what is called a VE charger. Or not VE, an EV charger. This thing is where the future of cars is trying to go. So, we're going to adjust the battery banks, and we're going to adjust everything, and we're going to do what we can to incorporate this into our setup. That way, those of you that want to get electric cars, if you put this setup in your rig, you know, and you continue watching my series, you'll know exactly how many batteries you need to run an EV charger, and you'll be able to take your EV car out there on the road with you, charge it up when you need to. I mean, crap, if you have a big enough battery bank, you could probably run your RV and charge a car and a couple of others or whatnot. It's something that I want to do because my wife does want to get an EV. And if the world's going EV, might as well start planning for it now. Now, this is our possible end result. This is a wiring diagram that I found on the Victron Electronics website, featuring a lot of the Victron parts. This part right here, this here, 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 and here are 4 alternators. We're building a single alternator system, but this here shows you can use 4 alternators in this system. To me, that might be a little overkill, but it is very possible to do. This one here that's in green and this one here that's in green, they're used to power a motor and work through to charge a battery without very much control in place. This one here is a 24 volt 100 amp alternator, and this one's a 24 volt 100 amp alternator, and they both have an independent charge controller with them. Now, I talked about being able to add solar panels. This here is a solar panel MPPT. This is your DC breakers for a solar panel array. And here's the solar panels. And they've got 2 setups for those. So you can see that it has been done. It has been wired together before. And this is our Quattro. We're only using one, just like what's right here. And this here spot is for shore power. This represents incoming current from a pedestal running into a DC circuit breaker, and it runs into our Quattro. This here's a generator with a battery to start it. And it runs through a DC circuit breaker right into the AC in for the Quattro. And then you got the lines that run out here to the circuit breaker panels to run right on out to your rig and power your house. Now, to get to the rest of these, this right here is what they have for a negative bus bar. All your grounds run right to it. And you can even see right here with this mint green line, it runs right to the Quattro, so everything's grounded. This here is 3 different positive bus bars. This is where everything comes into play, and this here is where all of the solar controllers come in. And then these three positive bus bars go and run through our protect systems, and then run right into our links distributors. Right here, they got 1, 2, 3 links distributors. Well, 2 links distributors that everything runs into, including your grounds and stuff. And this is your Cerebros. These are the battery protects. These are the switches that I was talking about. You got 2 here. You got 3 over here. It's a good idea to protect your systems. And then they have another links distributor right here, specifically for all 4 of their lithium batteries that they have in place. With all 4 of these lithium batteries that they have in place, they run to their own links distributor. Now, if you notice, there is no line, or like almost no separation between them. This here's a BMS. The 2 links distributors take these tabs on the end, and they can bolt to one another to combine positive and negatives. And then they can bolt right to the inside of the BMS. And then they bolted it right to another links distributor, which is also going to be our links power in. So this stuff is nice and neat. And as you can see, they decided to put 3 independent chargers on for the 3 lead acid batteries that are in the system. So we're not necessarily going to be getting away from lead acid batteries, but this does lay out a complicated diagram, and I am going to simplify it, and we're going to do a video going piece by piece. And this is pretty much the end result for anybody who has an RV. A lot of people like options. Why, you'd ask, why do you want to do the alternators and have them run at night if you have a generator? Well, the alternators are a good source of stable power. The solar panels, they only run during the day. The alternators, you can have them run at night. So they can run in conjunction with one another, but when one's not running, the other one can run. And if something breaks down between the two of those, then you have your generator that's already set, ready to go, that can power your house while you troubleshoot the other parts and get your system running back the way you want it to run. But our goal is to set it up to where you won't need the generator. Now, the way you could actually save on some of your time and your diesel is if you were hooked to shore power, which this system can handle. You hook it up to the shore power and you can still cut off all your other stuff, run your house, and change whatever distributors you need to. You can do an alternator check. You can do your lead acid battery checks. You can check your lithium batteries, make sure you haven't burned any of them out. And you can check out your Cerebro to make sure that everything is playing nice, or try and see if you found a spot where everything went bad. But this does prove a lot of my points. And in closing, I hope everybody that's watching is subscribed and maintains a good, healthy electrical system and can power their rig and have the options they need to get help when they need help. So thank you for your time, and please remember to subscribe so I know people are really interested in what it is I'm doing.